Europe is now understanding why the hydrogen economy needs to embrace all technologies and drive down costs for the hydrogen infrastructure and offtake agreements to develop. I'll go over this topic and give my thoughts on today's Hydrogen Podcast.
So the big questions in the energy industry today are: how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast.
In an article from oilprice.com, Alex Kamani writes, why Europe's hydrogen economy dreams remain just that. Alex writes, 4 years ago, the European Commission unveiled the landmark European Green Deal, wherein it laid out a series of policies aimed at making the region a, quote, climate-neutral bloc by 2050. Among the key policies, Europe set a target to consume 20 million tons a year of renewable hydrogen and install 62 gigawatts in electrolyzer capacity by 2030. Unfortunately, the continent is quickly acknowledging a cold reality. Hydrogen really is a hard sell. In its latest annual report, the EU Agency for the Cooperation of Energy Regulators, or ACER, paints a bleak picture of the state of the continent's hydrogen sector, saying those targets are unlikely to be realized without tackling serious challenges that include production cost and infrastructure. In a quote from ACER, the current renewable hydrogen consumption remains minimal, and while the EU renewable energy and decarbonization targets could drive the demand, uptake so far has been slow. Around 62 megawatts of electrolyzer capacity was installed in the EU at the end of 2023, good for a mere 0.1% of the continent's 2030 target. According to ACER data, EU countries consumed 7.2 million tons of hydrogen in 2023, a negative 2.5% year-over-year drop, mostly in chemical manufacturing and heavy industry like steel production. More than 99% of the EU's hydrogen supply was the gray type, processed using natural gas or other hydrocarbons. To be fair, the EU set those lofty goals 2 years before Russia's war in Ukraine triggered a global energy crisis, a situation so dire that even shunned sectors like nuclear have received a new lease of life. Since the beginning of 2022, Europe has been on a gas buying spree, adding more than 36.5 billion cubic meters, or roughly 1,289 BCF, in regasification capacity. According to the Institute for Energy Economics and Financial Analysis, Europe's import capacity could exceed 406 BCM this year, or 14.3 trillion cubic feet per year by 2030, as more import projects become online. Europe is not alone here. A few years ago, climate experts touted the outsized role that hydrogen could play in helping the planet limit catastrophic global warming. Indeed, net zero models have forecast that hydrogen could provide as much as 20% of the world's primary energy by 2050, nearly as much as all renewables currently contribute to the United States energy mix. Not surprisingly, there has been no shortage of big hydrogen ambitions. The European Union set a target to produce 10 million metric tons of carbon-free hydrogen by 2030 while importing an equal amount. Last year, U.S. President Joe Biden unveiled 7 regional hydrogen hubs that will receive $7 billion from the government as part of the bipartisan infrastructure law. Chile, Australia, and Egypt have laid the groundwork to produce green hydrogen for export. Meanwhile, China has announced no less than 360 hydrogen plants. Overall, companies and governments across the globe have announced plans to build nearly 1,600 hydrogen plants. However, hydrogen producers are facing one small problem. Few customers are stepping up to buy their commodity. According to Bloomberg New Energy Finance, or BNEF, just 12% of hydrogen plants have customers with offtake agreements. Even among projects that have signed offtake deals, most have vague, non-binding arrangements that can be quietly discarded if the potential buyers back out. The big problem here is that many industries that could potentially run on hydrogen require expensive retooling to make this a reality, a leap that most are unwilling to make. To complicate matters, green hydrogen made by electrolyzing water using renewable energy cost nearly 4 times as much as gray hydrogen created from natural gas or methane using steam methane reformation, but without capturing the greenhouse gases emitted in the process. Quite naturally, it's hard to build hydrogen infrastructure when the demand may not materialize for years. In a quote from BNEF analyst Martin Tingler, "No sane project developer is going to start producing hydrogen without having a buyer for it. And no sane banker is going to lend money to a project developer without reasonable confidence that someone's going to buy the hydrogen." And in a quote from Laura Luce, CEO of High Store Energy, "It's no different than any other energy development at scale. Natural gas pipelines didn't get built without customers." Laura's company has secured an exclusive letter of intent to supply hydrogen to an iron mill that Sweden's SSAB SA plans to build in Mississippi. The situation is quite dire, even in renewables-obsessed Europe. In a quote from Andy Marsh, the CEO from Plug Power, "If half of it comes to fruition, we'll be happy. If a quarter of it comes to fruition, we'll be happy." This Andy said to BNEF, referring to the company's 4.5 gigawatts in engineering and design work underway on European projects to generate green hydrogen. According to Marsh, EU member states are still incorporating their hydrogen roadmaps into their own regulations, delaying private investments. Werner Panakwar, CEO of hydrogen equipment maker ThyssenKrupp Nucera, says hydrogen projects likely to succeed today are ones that include the whole ecosystem. In essence, hydrogen plants located near a clean energy source with a ready customer close at hand. And according to Rachel Crouch, a senior associate at Norton Rose Fulbright, existing use cases for hydrogen, which today rely mostly on exclusively gray hydrogen, may be among the first green or blue hydrogen opportunities to be financeable because the offtake picture is already clear and easier to model. Crouch sees petroleum refining as one such area where bankable early green or blue hydrogen projects are likely to emerge because refineries are among the largest users of hydrogen as a fuel stock. She has also predicted that specialty vehicles will become big hydrogen customers because hydrogen is already being used to power fuel cells. Fuel cells are used in specialty vehicles such as forklifts and by energy consumers to complement electricity from the grid, to smooth energy costs, and to ensure reliability. Okay, so it looks like Europe is finally understanding what we've been talking about on this show since the beginning. If you think of the energy transition to hydrogen and other alternatives as a light switch instead of a gradual shift, and are adamant about only using one technology to get you there, you are destined for failure, or at least very slow progress. But let's take a step back for those new to hydrogen and break out what these colors mean. So, blue hydrogen is made from natural gas, with carbon dioxide emissions captured and stored thanks to carbon capture and storage, or CCUS technology. Green hydrogen, on the other hand, is produced via electrolysis, powered by renewable energy like wind and solar. It's the ultimate clean solution, but it isn't cost competitive or scalable. So then why in the world would you jump straight to green hydrogen when you have blue? Let's think about blue for a second. It offers a quick path to scale up the hydrogen economy. With countries like the US, Canada, and Norway already having extensive natural gas infrastructure, it can be repurposed to handle hydrogen. And it also allows industries like steel and cement to start decarbonizing immediately without waiting for green hydrogen to mature. And as the experts say, don't let perfect be the enemy of good. Blue hydrogen helps us start cutting emissions now. And you also need to think about economics. Right now, producing green hydrogen is still 2 to 3 times more expensive than blue. The reason is because electrolyzers, or the tech behind green hydrogen, are expensive to build and not yet widely available. Green hydrogen also relies on abundant renewable energy, which isn't always consistent or available everywhere. So by focusing on blue hydrogen first, we can drive early adoption, lower costs, and lay the groundwork for green hydrogen to take over in the future. And another reason to consider blue hydrogen first is its ability to utilize existing infrastructure, like I said earlier, like pipelines and refineries. But there is another hidden gem, and that's the CCUS factor of it. Scaling up blue hydrogen means refining CCUS technologies, which will be crucial not just for hydrogen, but for industries that can't easily eliminate carbon emissions, like aviation or heavy manufacturing. CCUS also creates a workforce and expertise base that will be invaluable as we shift fully to green hydrogen. But what about the social and economic impacts also? Blue hydrogen provides a soft landing for natural gas industries and communities reliant on hydrocarbon jobs, and it buys time to retrain workers and build renewable energy infrastructure without economic shocks like we're seeing in Europe right now. This approach ensures that the hydrogen revolution is as inclusive as possible. And this is why it makes sense to start with blue hydrogen. It's scalable, cost-effective, and helps build the systems we'll need for green hydrogen to succeed. And so is green hydrogen the ultimate goal? Well, maybe, depending on what region you're in around the globe, how much access you have to renewable energy, and how much access you have to clean water. And also, don't forget about other very clean hydrogen development technologies like methane pyrolysis and even natural hydrogen. Two other technologies with very high potential that also need time to scale. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another.
Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.